Good afternoon, everyone. Welcome to the class on operation research, where in today class we'll discuss the previous year question paper of operation research for the year 2016, and we are discussing the topic called transportation problem. In transportation problem, we are discussing the test of optimality, and I believe you already know that whenever we have a transportation problem, the cost metrics what should be it should be the minimum cost metrics where your objective function should always be minimization of cost. And under that scenario, when you're working on the transportation problem, what we need to look into the scenario here is that we can find the initial basic feasible solution. Either we'll follow northwest corner method, or we'll follow matrix minima method, or we follow a Vogel approximation method. By using any method, we'll by using any method we'll find the initial basic feasible solution. Once we find the initial basic feasible solution, we can find the optimal solution, guys. We can find the optimal solution. That optimal solution is found by using the method that is called modified distribution method, or that is also called as UV method. So when the UV method we can only apply once we find initial basic feasible solution. Once we find the initial basic feasible solution, then only we can use UV method to work on the test of optimality. Okay, so here, if you see the problem which we're gonna discuss today, So this is question number 20, and this came for the year 2016. So in the year 2016, if you see this problem which came for 10 marks, here they expect us to find optimal basic solution, basic feasible solution here. So and they've given us the 10 marks. So in case ever, if you see a transportation problem where they have given you 10 marks, it means that you have to find the optimal solution, guys. Now, here they have not mentioned that which by using which method you have to find the initial basic feasible solution, and then to work on optimality, because that method is not given. So we can use any method here. So I, out of all the three method, northwest corner method or Vogel approximation method or by matrix minima method, I like northwest corner method, easier to do. But like, guys, one thing you need to understand, like, by using any method you can find the initial basic feasible solution. Okay, but once you get the initial basic feasible solution, guys, then you need to understand that out of the three method, either it is northwest corner method, or it is matrix minima method, or either it is Vogel approximation method. Guys, you need to understand, out of the three method, the give you the value which is very close to your optimality, that will be Vogel approximation method only, guys. So please understand, the method which can give you the value which is close to optimality, that will be Vogel approximation method. So if ever you have to choose one method out of the three method to get the optimal solution, my sincere suggestion for all of you is to use Vogel approximation method only. Okay, that is my sincere suggestion to you. But here I purposefully I'll do it by northwest corner method. I want, because if you use northwest corner method, or if you use least cost or matrix minimum method, definitely your iteration steps to work on optimality, that will get increased. So I want to complicate the scenario. So because tomorrow when you do this problem in exam, you may also get stuck with complication. So I want the looping should be formed. So how we can work on looping, that I wanted to get away from it. So that's the reason why I'm doing this. So here we have this problem. Now, if I use northwest corner method to work on optimality, okay, then what? Then if I talk about that allocation, you can see for the first cell you have 2 units, and demand is 4 units. So the maximum you can put is 2 units. So nothing can be put for this. So this left is 2. Okay. Then for the next cell, you'll put 2. Okay. Okay, you'll put 2 and this is done, and the availability left is 1. Okay, then you'll put here 1, here you'll put 1. If you put here 1, so means here done. So now you can see here you'll put 5. Okay, so you see this is a solution what you got, guys. So the solution what I got, the solution what I got, let me, do I have a pen or pencil? So 1 minute, let me take the screenshot of this. This is the solution what I got. 1 minute. Now this is the solution what I got. Fine. Now let me just erase this. So once I got the solution, now if I see the the initial basic feasible solution what I got, let me copy the data. So 7 allocation is 2, then 3, then 2. So once you get the optimal solution, that's total supply, total demand, doesn't make much sense here. Then 2, 2, then 1, 1, the value 1, 1, then this is 3, then this is 3, then 4, and then 6, this is 5. Okay. Now, guys, if you see the test of optimality, you have 3 rows and you have 3 columns, correct, right? So total number of allocation should be 5. But if you see the total number of allocation here, total number of allocation here is 4. So if you see the test of non-degeneracy, if I do test of non-degeneracy, if I do test of non-degeneracy, if I do the test of non-degeneracy, then the total number of allocation, should be equal to m plus n minus 1. So the total number of allocation should be 3 plus 3 minus 1. Means there should be 5 allocation. But here the total number allocation is only 4. So here if you see here the total number of allocation, here the total number of allocation, here the total number of allocation is 4. Okay, so here the total number of allocation is 4. It means the given solution, it means the given solution, it means the given solution degenerate. It means the given solution is degenerate. It is not non-degenerate. So we expected it to be non-degenerate, but here it is degenerate. Okay, so this part you can understand. Now, when we work on optimality, so we'll write here U1. Okay, here I'll write U2, here I'll write U3, here I'll write V1, here I'll write V2, here I'll write V3. So out of U1, U2, U3, V1, V2, V3, we'll put one variable to be equal to 0. Okay, so see whichever row or column you find the maximum allocation, and you can call that, you can put that variable equal to 0 under UV method. Okay, so I've done that. So you can see your occupied cell. So this, what are your occupied cell? This is occupied cell, this is occupied cell, this is occupied cell, this is occupied cell. So remember this, for the occupied cell, for the occupied cell, for the occupied cells, we use the formula. Whenever we, for the occupied cells, we use the formula that Cij is equal to Ui plus Vj. So we use this formula for occupied cell. So when we use UV method, then for the occupied cell, we use this formula, while for unoccupied cell, while for non-occupied cell or unoccupied cell, while for unoccupied cells, while for the unoccupied cells, we use a formula called Cij minus ui plus vj. While for the unoccupied cell, we use this formula. So this is how we need to do. Okay, so this is how we need to do. So I hope you're understanding what is UI, what is VJ. So this you can understand the metrics part. You have already done in your first semester, I guess so. So first or second semester, you did metrics part. Yeah, I believe first semester only descriptive mathematics. Okay, so there you know what is A11. A11 means first cell, first row, first column. A12 first row, second column. A13 first row, third column, like that. So with this you can do that allocation. So the Cij, like if I say C11, so C11 is 7. I hope you're understanding. What is C11? The cost value. The allocation is something else, cost is something else. So you can I hope you people can easily understand this. Where is the allocation? What is the cost? So this part and all, I hope you people can easily understand. C11 means 7, first row, first column. Okay. So then this is occupied cell. What are occupied cell, guys? Here, what are your occupied cell? Your occupied cell, if you want to find your occupied cells are C11, which is 7. Then you have C21, which is value cost is 2. Then C22, the cost for that is 1. Okay. Then C33, the cost of that is 6. Okay. These are occupied cell. I hope you are understanding. These are the cost element for the occupied cell. While for non-occupied cell, while for the non-occupied cells, while for the non-occupied cell, C12 is 3. Okay, then C13 is 2. Okay, then C23 is 3. Okay, then C31 is 3. Okay, and then C32 is 4. I hope you can find their cost very easily. So the for the occupied cell, what is the cost? Okay, for the non-occupied cell, what is the cost? That part clear with everyone, right? So what is the cost for the occupied cell? What is the cost for the non-occupied cell? That you can easily see, that you can understand that part. Clear everyone? Anyone, any doubt? Once you get that, now I'll focus on only on occupied cell. So we'll focus on occupied cell. So first we'll focus on occupied cell, and what we try to do, guys, by focusing on occupied cell, what we try to do, guys. So by focusing on occupied cell, I try to determine the values of U1, U2, U3, V1, V2, V3. I'll try to find their values. So first, by focusing on occupied cell, so by focusing on occupied cell, by focusing on occupied cell, by focusing on occupied cell, the values of U1, V, V1, V2, V3 are determined. Here, anyone, any doubt? So by focusing on the occupied cell, I'll try to determine the value of U1, U3, V1, V2, V3. Already U2 value I put as 0. I assume, let assume U2, let assume U2 equal to 0. So I assume U2 equal to 0. Clear everyone? I hope you people understanding this. Now what I'll do, if you see, guys, so if I put U2 0, then V1 will be 2 and V2 will be 1. Very simple. So you know that because I assume the U2 is equal to 2, so I can find very easily the C21. C21 means U2 plus V1. C21 is 2 and U2 is equal to 0, so V1 will be equal to 2. And similarly, C22 is U2 plus V2 and C22 is 1, U2 is 0, V2 will be equal to 1. I hope you people understood this. Then I can find the value of u1. So if I focus on c11, u1 plus v1. So c11 is 7, u1 I don't know, v1 was 2. So I find the u1 I found the value to be 5. Okay. Now because no, if you understand, because this is not the solution what you get, no, that is non-degenerate solution, right? The solution what you get is non-degenerate, right? Why it is non-degenerate? Because the total number of allocation ideally it should be 5, right? But here the allocation is 4 only, because you have the total number of allocation which is not equal to the m plus n minus 1 rule basis. Definitely you will not able to do now the allocation. Now what we'll do in order to make sure that we can do the allocation, we assume what we do. Let assume a variable. Let assume an allocation called epsilon. Okay, let assume an allocation here. We call that allocation called epsilon. Okay, we'll assume that allocation as epsilon. Okay, let assume this allocation called epsilon to be put on the minimum cost value, to put on the minimum cost value, where is the cost value minimum. So let assume an allocation called epsilon, which you put on the minimum cost value. What is the purpose of doing this? The purpose of doing this is to complete the allocation. Now you have to find the value, right? U1, U2, U3, V1, V2, V3. You have to find the values, right? So what I'm trying to do, guys, I'm trying to assume an allocation called epsilon, which I'm putting on the minimum cost value, which is, that is, what is that value? That value is A13 called 2. Okay, having so this what is this epsilon? Epsilon is a dummy allocation. It is the dummy allocation. It is a dummy allocation. Epsilon is basically, it's a dummy allocation. Okay, the epsilon is a dummy allocation which I'm putting on the minimum cost element, guys. Here, out of in the matrix, in this matrix, we'll figure out the value which is the minimum. In case of what you say, in case of uh, if the two values is having the minimum value, then we'll choose that variable which is not impacting the overall solution. Okay, so we'll put this dummy allocation, which we called as epsilon. Okay, and that we put on the minimum allocation, like, so that it should not impacted the allocation which is done so till now. So which will put a minimum cost value, like whichever is the minimum cost value, we'll put on that, we'll making sure it should not impact, it should not impact the allocation done so far. It should not impact the allocation done so far. Done so far. Fine. So let me just check this. Let me check the allocation. Let me check the allocation. So let me check the allocation which is being done till now. So if I see the first one, the for the allocation, you can check cost was 7, 5 plus 2, 7, correct? Okay, allocated cell. Then second one, then you can see this here. The second till now allocation, don't touch any new allocation, just check everything should be appropriate. A21, yeah, 2 correct. Then A22 or C22 means second cell, C22. So 1 correct. Okay, then yeah. So till now it's not impacted anything. Now, because you have put epsilon on the minimum value, which was 2, now what I can do, I can find the value of V3 and U3. Okay, how I can find? Because now I got C13, and that will be equal to U1 plus V3. So cost of that is 2, U1 is 5. So I can find the value of V3. So V3 will be equal to -3. Once I get V3 value equal to -3, so I can find U3 value. I can find U3 value. How will I find U3 value? So C33 is U3 plus V3. So C33 is 6, U3 is -3. So V3 value I'll find that will be equal to 9. Clear, everyone? So with this, I just got with this I found U1, U2, U3, V1, V2, V3 values, guys. So with this, I found all these values U1, U2, U3, V1, V2, V3. All these values I found, guys. Clear, everyone? Now focus on the cell which are unallocated. Now focus on the cell which is unallocated. Now focus on the cell which is unallocated. So till now, you focus on the cell which are allocated and you got this value. So now what you'll do, you'll focus on the cell which is not allocated. Now what you'll do for the non-allocated cell, now for the unallocated cell, for non-occupied cell, for the non-occupied cell, for the non-occupied cell, use the formula Cij minus Ui plus Vj. Okay, so find the value, and if 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 for all if for all non-occupied cell, if for all non-occupied cell, if for all non-occupied cells, okay, if for all non-occupied cell, if Cij, if for all non-occupied cell, if Cij minus Ui plus Vj is positive, means the allocation is optimal. It means your allocation is optimal. In case if it's not positive, then we'll work on the negative allocation to see what we can do for optimality. I'll show you that part first. For the time being, you just see this. Now I'll focus on non-occupied cell. So which I made colored with green color. Those are non-occupied cell. Now I'll work on this. Now I'm going to use this formula for them. Cij minus Ui plus Vj. Okay, everyone. So let's do this. So the first non-occupied cell is C22. So you'll apply the formula called C22 minus U2 plus V2. Apply that. So U2 plus V2. U2 C22. No, it's actually C12 actually. Yeah. This is C12. This is U1. So this is C12. The cost here is 3, and U1 is 5 and V2 is 1. So it will become 3 minus 6, means here value is -3. Okay, so means for first only when you get negative value. Then second one, if you see the second one is what? C23. This is negative, so means now its solution is not optimal. Then C23 means C23 minus U2 plus V32. 2 is -3, and U2 is 0 and V3 is -3. So 0 -3 C3 minus -3 will get positive. So if you're getting positive, good. Then C31, so means U3 plus V1. So you get U3 is 9 and V1 is 2. 9 plus 2, 11. So 3 minus 11. 3 minus 11 is -8. Negative allocation, this is 10. 9 plus 1, 10. This is 10 means -6. 4 minus 10, 6. So you see, out of all negative value, which is the maximum negative value. So you can see the maximum negative value is A31. So we'll do the allocation of this first. Okay, the maximum negative value is A31. So we'll do the allocation of this first. What you do when you do allocation, put your cursor here, okay, and only go on occupied cell, okay. We'll only go on occupied cell. So what I can do, make a loop like this, okay. We'll make a loop like this, make a loop like this. You have to complete this loop like this. You have to make a loop like this. You have to make a loop like this. Okay, so you have to make a loop. So here, if you see, so if you see this loop, so here put the value theta. This is put the value theta, put plus sign. This would be minus sign for the allocation. This would be plus sign. This would be minus sign. So this value, if you see this is theta. Okay, this value is theta. Then here, this value will be 5 minus theta. Allocation of that cell was 5, and do this. If because put minus sign, so write that at 5 minus theta. This will be epsilon plus theta. This value will be epsilon plus theta, and this value will be 2 minus theta. Then what you do, out of all negative theta, x minus theta value, see which value you can give to theta. So out, consider only negative value here, consider here negative value, and see which is the minimum out of that. The minimum out of that is 2. So it means theta, put theta equal to 2. So 5 minus 2, this will be 3, and this is 2 plus epsilon, and this will be 0. Now this would be your new allocation. This would be your new allocation. So again, what you do, again you write the allocation, again you'll find the value till the time you'll not complete, till the time you get all positive for non-occupied cell. Okay, everyone. So this is the process what we'll keep playing. This is the process what we'll keep doing. So now this allocation, whatever allocation you did, whatever allocation when whatever allocation I did, I just write it down my allocation again. I just write it down my allocation again. So you can see this is 7. This is 7. So that was 2, no? That was negative value 2. So that I took as theta. So now it has become unoccupied. So 7. Then this is 3. 7, 3. Then this is 2. Then this is 2, and the value what it got was what? The value it got is 2 plus epsilon. No? The value what you got was 2 plus epsilon. The value it got was 2 plus epsilon. Okay, and then 2 2, then it is 2 2. Okay, then 1 1 1 1 1 1 1 1, then 3, then 3 3, then here this is 3, and this is 3, and the allocation of this would be 2. The allocation of this theta would be equal to 2. The allocation of this would be 2. Okay. Then 4, then this is 4, and then this is 6, then this is 6, the 6, then this is 6, and the allocation of this would be, the allocation of this would be 5. So 5 become 3. 5 has become 3. 5 has become 3. Okay, now this is the allocation what we did. Now again, right, this is u1, this is u2, then u3. Okay, then write this as v1, write this as v1, then v2, then v3. Okay, then if I put this equal to 0, we see where is the maximum allocation, put that 0. So then this will become 2. Okay, apply the formula. Cij is equal to ui plus vj for occupied cell. This become 2, this become 1. Okay, then this become 1. Okay, then this become, well, 5. Okay, then if this is 5, this become minus 3. Okay, this then means u1, u2, u3 we got, v1, v2, v3 got. Now for unoccupied cell, use the formula Cij minus ui plus vj. So you can do that allocation. So this is minus 3 plus 2 means minus 1. 7 minus minus 1 will get plus. Then this is 1 minus 3. 1 minus 3 is minus 2. So 3 minus minus 2, that is plus. Then this is 5. This is minus 2. 3 minus 5. Okay, this is 2u positive. Okay. Still you get negative value here. Okay. Still you get negative here. Now again we'll create the loop. So this time when we create the loop, this make the loop like this. Okay, make the loop like this, plus sign, then minus sign, then plus sign, then minus sign. Make the loop like this. So whatever you like, this 3, no, 3 is having negative allocation. So I want that value, so make that as theta. So this will be the next value, that will be 3 minus theta. And this next one, that will be 2 plus theta. And then next one will be 2 minus theta. Again, you know that out of negative theta value, the minimum theta is 2. So here theta will be equal to 2. So 3 minus theta will be equal to 1. 2 plus theta will be equal to 4. And 2 minus theta is equal to 0. I think done with your allocation. Again, we'll test that. The answer we get, again we test. So 732, then 732. Let me write it down. So 7, then 3, then 2. The allocation was 2 plus epsilon. 732. The allocation was 2 plus epsilon. Then 2, 2, 2. The 2 we have taken, no, 2, 2, 1, 1, 2, 2, 1, 1, 2, 1, 1. Okay, 2, 1, 1. Yeah, because this 2 I have taken, right? This 2 I have taken. Yeah, this made 0. So 2, 1, 1, then 3. And here 3 become 2, right? Here the 3 got the allocation 2. Okay, then here this is, then this is 3, this become 5, no? This become 4. 3, then 4. This 3 become 4. Okay, then allocation, it was 2 and plus 2, because theta become 2. 4 and this is 4. This is 4 and this become 1. This become 4. This is 4. You, and this is 6, having to become 3 will become 1. 6, 6, then it become 1. 6, it become 1. 6, it become 1. 6, it become 1. And right, this is u1, this is u2, this is u3, this is v1, this is v2, this is v3. This put this 0, this become 2, this become 3, this becomes 6. Okay, apply the formula. Cij is equal to ui plus vj. Okay, then this become minus 2, this become minus 2. Okay, this will become 3 minus 6, minus 3. Okay, you got all this now. Now work on non-occupied cell. Now work on unoccupied cell. Now work on unoccupied cells. So unoccupied cell. So first one, minus 3 plus 2 minus 1. 7 minus minus 1 positive. Then minus 2 plus 2 0. So 3 minus 0. So that would be 0. Then minus 3 plus 3 0. So 2 minus 0 0. Then minus 2 plus 6, it becomes 4. 4 minus 0, 4 minus 0 0. So I hope you understood what formula you need to use, guys, here. The formula what you need to use here, that for the occupied cell, you remember, right? Already I told you for occupied cell, you use the formula called Cij is equal to Ui plus Vj, and for the unoccupied cell, unoccupied cell, for the unoccupied cell, for the unoccupied cell, you use the formula called Cij minus Ui plus Vj. Clear, everyone? So now you can see all your allocation, all are giving you positive value. Clear, everyone? So for occupied cell you got, and for the unoccupied cell, for unoccupied cell we use this formula. You can check this. Okay. So yeah. So once you check these values, guys, once you check these values, so your work is done. So you can see for occupied cell, for the unoccupied cell, I'm getting positive value. So once that part is done, means my solution is optimal. So if my solution is optimal, so I can find my optimal cost. I can find my optimal cost. I can find my optimal cost. So my optimal cost here, epsilon means, understand, epsilon is like dummy value. It have no value. So it's like zero something. So this would be 2 into 2 plus epsilon means zero only. Okay. Plus 1 into 1. Okay. Then this is 3 into 2 plus 3 into 4. Okay. Then 6 into 1. Okay. So this is 2 into 2 plus 1 plus 6 plus 12 plus 6. So this is 4, 4 plus uh, 4 plus 7, no? 4 plus 7 plus 18. So this is 22. 4 plus 7, 11. 11 plus 20, 18 is 29. So optimal cost would be 29. Clear, everyone? So this would be your answer, guys. So if you do this much, you will get the 10 marks. Done, everyone? Okay, fine. So, okay, Srinivas, I'll end the class. I'll see you on Monday. Thank you, everyone. Thank you, Srinivas. Thank you, everyone. Yes, yes, I'll do that, Srinivas. Okay, everyone. I'll see you all on Monday. Thank you, everyone.